Hello students, welcome all of you. This is my lecture number 8 of the topic Surface Chemistry for class 12. This is the continuous lecture from previous lecture 7. In last visual we have seen the types of catalyzed reactions. There are two types of catalyst, homogeneous as well as heterogeneous catalyst. Now we have to discuss the mechanism of heterogeneous catalyst. It means solid heterogeneous catalyst. As we know, the surface of solid, example is metals. It contains large number of free valencies. It means it contains large number of active spots. These active spots responsible for chemical reactions. Chemical reactions with adsorbate molecules, gas, liquid by adsorption concept. First of all, the adsorbate, that is a gas, liquid molecule diffuse on the metal surface, that is catalyst. Second point is that the adsorption process takes place in between catalyst and diffused gaseous molecule. Then third step is that the formation of activated complex, due to reaction takes place in between adsorbent and adsorbate molecule. And close proximity structure of adsorbent, that is catalyst of metal. Now the following step take place after the formation of activated complex. The deadsorption process takes place in between adsorbent and adsorbate. And lastly, the removal of product species after the chemical reaction. The reactant molecules changes into the product species, so that lastly the removal of product species from the surface of metal catalyst, so that we can get the product. These are the following steps involved in heterogeneous catalyst. Now we have draw a chart to understand the following steps. As we know, first of all, the metal surface, this is the metal catalyst. There is a large number of free valency, and these free valency which are responsible for chemical reaction, first of all, like A and B molecules. This is the gaseous molecules which diffuse the layer. This diffuse the layer of these surfaces. First of all, diffusion. First step is diffusion. This is the metal surface. Diffusion. Next step is that second step, the adsorption. After diffusion, there is an adsorption process takes place between adsorbent, this is the metal catalyst, that is adsorbent, and this is the adsorbate. Adsorption takes place. First step is that formation of activated complex. A, B, formation of this activated. First step is formation of activated complex. Third one is formation of activated complex. Then after, next step, after the chemical reactions, the deadsorption takes place. Fourth step is that deadsorption process takes place. Deadsorption process is that the tendency to adsorbate molecule remove the surface of adsorbent. And last step is that fifth step, that is last step, the removal of product from the surface of catalyst. It means catalyst is working simply as the rate of reaction becomes fastened without use of. Catalysts do not participate in chemical reactions. Then lastly, fifth step is the surface of metal remove from this one and product molecules to be formed. Catalyst simply used of the catalyst simply do not participate in chemical reaction, simply it helps the chemical reaction takes place. This is the following steps in which heterogeneous catalyst reactions takes place by following steps. Now we have to discuss some of the characteristics of heterogeneous catalyst. Characteristics of solid heterogeneous catalyst. First point is that activity. Activity means there is a strong chemical adsorption takes place between adsorbent and adsorbent molecules, so that the greater yield of product formations. The activity, it is the property in which a strong chemical adsorption takes place in between adsorbent and absorbent, that is gas or liquid molecules for chemical reactions, so that greater yield of product formation. And second important characteristics of heterogeneous catalyst reaction is that is selectivity. Selectivity means for particular catalyst there is a selective product to be yielded. Selectivity which refers the desired product to be formed by using appropriate catalyst. Like example of H2 in presence of Cu, when we react with copper and heating, then it forms formaldehyde.